Hello, this is Lily Morningstar, your instructor at College of Southern Nevada, and today in class CAT 217 Security Plus, we will be talking about application security. Chapter 7 will be covering application development and security. After completing this chapter, students will be able to summarize application development, discuss the software development life cycle, and examine um, different development models, recognize tools for secure application development, identify secure coding techniques, differentiate between white box and black box testing for secure code reviews, discuss various application vulnerabilities, list common types of application attacks. What is application development? Basically, application development is the process of creating applications. Applications is a software, and usually application development is a process that requires multiple people working on a multiple projects simultaneously or in order depending on application development process. We need to cover a term environment, and environment is the resources that host the application. Environment can be software-based tools used by developers to create applications and software. It also enables developers to create code without risking of interaction, and will be using multiple environments used in the application development process. Application is a software program, as we mentioned earlier. We often can hear something that called web app. Previously, we used to call websites, but now when we have majority of software available and running completely web-based online, we would call them web app or web applications. Let's talk about environments. Application Development Environment, or ADE, is a compound of hardware, software, and resources that enables developers to build these web applications. Test environment. Test environment is a controlled environment in which the components of the software are tested, and often it's called as QA environment, which stands for quality assurance. Quality assurance is activities that would identify different mistakes or vulnerabilities in applications. Sandboxing, when we are trying to test our application in a closed, isolated environment without exposing this application to the outside world. And if there are any issues or errors in this application, they will not escape the sandbox. Staging environment is pre-production environment, the environment that we would use before the application will see the world. Quality control is the type of actions that verify integrity of the application and make sure it meets all expectations. Production environment is different. Production environment actually is a setting when we are running application used by intended audience, and it's usually in real time, and it would act similar as if we had this application run and used by users. It's usually a final step of application development process. On this slide, you can see an image of all processes that take web application development process. So first you can see is business model identification, what this application should be, what is the reasoning of building this application, and financial background of this application. Business process analytics, how this application would affect business. Technical proposal review, what technological needs and expectations from this app would be. Then process of application development is actually when application would be developed and designed and implemented through the programming and organizing, and then will be monitoring and analysis control. Before application will see the world, we will need to make sure this application meets our expectations. We will test it in production environment, and when we finally release this application, we will need to make sure we continuously monitoring and analyzing this application for errors, mistakes, and different vulnerabilities that could expose clients' data on the app. Development and training is necessary when application will be released to the real world. We need to train people to interact with this application. Maintenance and support should be necessary because the applications need to be constantly troubleshoot, and in case of different technological issues, these issues need to be fixed immediately. Here on the slide you can see software development life cycle, or abbreviation for this will be SDLC. Please make sure you memorize abbreviations and know what they stand for. So let's see how this development life cycle works. Let's start with design. So we design our application. We proceed into implementation. So we wrote this application and now it's implemented. Then we proceed to testing. When we test application, how it works, if it has any bugs or errors. Evolution, which means advancement of this application, adding additional features. Requirement analysis, if this application meets our expectations, and if it's not, we need to proceed to design and add new features to it. Conceptual process used to create and deploy and maintain the software application is a part of the software development lifecycle. Another name for this would be software or application development process. You can see different SDLC models: waterfall, agile, and DevOps. All of these models will be discussed in a moment with you. First would be waterfall development. Development lifecycle model that follows sequential process and each step completed before the next step. So first step would be gathering, analyzing requirements, where we will determine why application is needed. Then we will proceed into design, and in the design process we will see what is the planned results and expectations in this product. After we will design our application, we will proceed into coding, which is basically a programming stage where we'll our programmers, developers will write a code for this application to work. Once code is complete, we need to test this application. And in this stage, application is tested in a testing environment. After application complete all testings, it's ready for deployment. Basically, when we release this software to the end users. And in case application has some bugs that we have not identified during the testing stage, we will proceed into maintenance, where we will be do updates, patches, upgrades to the application. Agile development model is little different. It's development lifecycle model in which solutions evolve through the team collaborations, everybody working on this project at the same time. And it's created to overcome sequential nature of waterfall model. And agile model enables the ability to perform a number of different tasks simultaneously. And on the next slide, we will see how the work will be broken into different blocks. These blocks called interaction, and when different parties of this team will work collaboratively and evaluate each other work until it's complete. Usually this model is more rapid and it allows us continuously deliver the software and release the software at the same time of developing and um, supporting this and designing this application. Agile development model and interactions. So on the left side, you can see Agile core values. We have individuals and interactions over processes and tools. So different software for project management would be useful in this type of environment where individuals can actually cooperate and work with each other and communicate. Working software over comprehensive documentation. Basically, when a team of developers have to make sure they deliver working software. Customer collaboration. Customer collaboration will be also part of this team where we will address their needs in the first place and responding to changes. If there are any changes need to be implemented during the process of developing software, they will be addressed almost immediately. So let's check the image on the right side. Iteration 1 is requirements, design, build, and test. We will proceed to iteration 2, where we will get again requirements, design, build, and test, and then iteration 3. And then we will be able to deploy this software. DevOps. This is a fancy term that basically describes continuous, never-ending process of planning, building, testing, and coding, and releasing and monitoring the software. So as you can see, it's described as a philosophy, and it also incorporates security concepts in the process of developing software. Often you can hear the name Agile Operations because it's based on Agile model. Infrastructure as a code. IAC. That's another abbreviation that you need to memorize for the exam. Management of the hardware and software through the machine-readable files as opposed to physical configuration. Automation is the process when no as much human interruption and intervention needed because everything is scripted. And script is a custom files with commands that tell to the different processes when they need to start and what they need to do. DevOps life cycle. DevOps life cycle is always starts with continuous. So it's never ending process. Continuous integration, continuous delivery, continuous testing, continuous deployment, continuous validation, and continuous monitoring. How we would securely deploy, proceed to the deployment of application? First of all, we need to make sure that we tested our application for security flaws, for different vulnerabilities, and fix those vulnerabilities before application had been released to the end user. So AppSec, or application security, should be happening during development process, not after. And provisioning is the practice of providing access and resources to the network services needed for employees to complete their job. Deprovisioning is removal of those resources and accesses for the team members. Software diversity. As word diversity means all different backgrounds and different cultural and different just word different, right? In word diversity. Same with the software. It's a type of security approach when we use diverse software to create our secured design for application. So we will use different software and transforming this software into different forms. And we will enable software to adapt to all customers' requirements and needs. Predictive analysis is really important term when it comes to software diversity and web application and application in general development. Predictive analysis is when you examining the data, when you create a statistical model and you involve machine learning and AI that will help you to identify flaws in your application before you even would be able to release this application to the end user. Compiler is program that converts written code in programming language into machine language. And binary is a file, and this file must be interpreted by a program or hardware processor that knows in advance how to read this file. In Linux, you often can hear word binaries when we talking about files that run applications or processes. Scalability is really important. Often this term will be used with cloud computing, but basically it's ability of the program to increase or decrease depending on the needs of the customers of this application. And scalability also comes with the resilience, which part of the creating secure application. So system will be able easily to recover from any type of disruption or any type of incidents. Load balancing and load balancer are really important terms when we're talking about scalability. So load balancing is distribution of different processes over multiple servers. When one server is not available or been attacked, the rest of the servers that are using load balancing will take the load of that one server on themselves, and users of application most likely will not even be able to see any difference in using this application. And load balancer is the device that uh, allows us to implement load balancing between various servers. Elasticity is another term that we often can hear when we're talking about cloud computing, and its ability of application to change resources dynamically as we need them. So it says it's similar to scalability, but with elasticity, it's more focused on expansion or reduction of capacity. Time-based elasticity is basically automatic shutdown of resources when this resource is no longer needed, and volume-based elasticity based on the scope or how many inquiries on this program right now needed. Integrity measurement. Baseline is a assigned way how something should be implemented. So secure baseline would be defining objectives and statistics that all applications must meet. And it's usually a set goal, and based on the set goal, we will measure how successfully this application had been developed. We can compare and analyze application based on the baseline. There is a joke, there is no problem with baseline if there is no baseline. But every application should have some sort of baseline, or what we would call it as a blueprint that we will need to use in order to build our application. Version control. While we're developing our application, we will have multiple versions of this application. And another word of version control would be source control, because we will be controlling source code for this application. But basically, it's a tracking mechanism of all versions of our source code and of all versions of our application through the development process. And change management, when we implement optimization change to provide a better environment in our application. As you can see, change management software would require us to run documentation. So just like any change management in our network and organization in web applications and applications development, we also need to make sure we use strongly documented change management. Secure coding techniques. If you never heard before about OWASP, I would suggest you to Google OWASP, or Open Web Application Security Project. It is a non-profit organization, and it helps developers to identify multiple vulnerabilities for web applications and help them to implement secure coding process when they develop these applications. It also gives guidelines how to handle errors and what would be improper error handling. Input validation is one of very important processes when we develop application. Or another term would be form validation. It's programming configuration in which input fields, and we all remember all these web applications where we have to enter our login or password or our personal information. So that's the input fields. And we need to make sure those fields will reject any characters that do not match or have malicious intent in them. And improper input handling would be lack of this input validation. Basically, when someone can enter some malicious request through this form and as a result receive data that should not be visible to the user. Injection attack is something we will discuss in the future a little bit more in details, but basically it's an attack when hacker will be able to enter different codes and get access to the server, get access to the database, and so on. On the right, you can see a meme that's quite famous in cybersecurity. My name is apostrophe or 1 = 1. And basically, this is SQL injection code that will, if we don't have input validation, that will release database through the front end web application. And input validation would be on the client side and server side. The difference between them is very important, and also we will discuss this in a moment. So client side validation usually is easy to implement. It's basic validation for user input fields through the web browser. And it's usually faster than server side because you don't have to go through the all the code on the back end. But it's also less secure. And as you can see, it states that every mistake can be corrected. But on the left, there are a picture that pretty much explains this client-side validation. So in order to call 911, you should only have available buttons 9 and 1. That's very much self-explaining what is client-side validation. However, the server-side validation takes a lot of time. It's often harder to do, and it's most likely guarantees the properly formatted input. So it's also funny meme about Adele singing, if she was a web developer, hello from the server side. And you probably would assume that web developers don't really like to do server-side validation after application already released, because again, it's harder and it takes time. Normalization. When you hear normalization, often it's when we're talking about databases in applications, and basically when we structure our databases to consume less storage and make sure that we don't have repeating entries, and database is stored in a single location. Basically, when we structuring and organizing our database. Obfuscation. So obfuscation in general means when we are adding some type of junk data into our code to make this code do not look like real code. So we're not encrypting this code, but we make this code sort of to be hard to understand and less useful if somebody would be able to see our source code. So code obfuscator is a program that makes automatically this code to be difficult to read. Source code is original code before it's been compiled, and compiled code when the code ran already through the compiler and now it's can be used by CPU. Basically, those zeros and ones. And compiled code also can be translated and reversed. Uh, if you know how to use assembly, assembly will help you to read machine code, but you also can use program decompiler, and it like Ada Pro, for example, and you will be able to reverse engineer the code. Then comes handy something that we would call as camouflage code. Is just the code that written the way that it makes difficult for someone to read, understand, or reverse engineer. Why would we need such a tool? We don't want anybody to, like competitors, to steal any parts of our code and reuse them, or we don't want malicious actors to write malicious software that would allow them to attack our application. Code reuse. Software developers often reuse and recycle their old code, and this practice should not really exist. It's unsafe and unsecure practice. And if you see this funny meme, when they reuse the code and instead of actual bot they're using this kangaroo, that's pretty much what happens when uh, software developers being lazy and decide to reuse and redesign lines of code they already had. However, there are not always codes that need to be written from the scratch, and often, especially unexperienced web developers would use codes from the different libraries, and library collection of programming codes publicly available on GitHub, and is not often a bad practice, especially at the beginning when the web developers just learning how to write their own codes. But when it's a large organization that develops some software that needs to provide security, those developers must make sure that code that they use from the library is actually secure, because anybody can write the code and publish it on GitHub. But what if this code is actually not secure? SDK, Software Development Kit. It's a collection of software development tools in one package. And many developers use it, and nothing wrong about using it. Just make sure when you using codes from the library, you actually know how to troubleshoot that code, how to read this code, how to understand this code, And of course, you know how to test this code for the security flaws. Code signing is when you adding a code signature to application. So this signature will actually authenticate you as a developer of this code. And it's digital signature, obviously. Memory management. Any application, any process that running on a computer would require a memory. And it's important to be able to create applications that would not require a lot of memory use. For example, bad example actually of application that uses a lot of memory would be web browser Chrome. If we're using web browser Chrome, we can see that our computers have slowing down, and when we check processes, we would see that Chrome is basically swallowing all our RAM, all our memory. We also have to consider that any data that in the memory also can be security risk, because in the memory it's basically in the working process, and it can be also a vulnerability. So garbage collection. Garbage collection is important when we trying to implement secure memory management. When any data that's stored in the memory and no longer needed and in use will be actually automatically completely removed from the memory. Secure HTTP headers. So what is HTTP header? It's just block of data, and it has different fields, and we need to make sure those fields are properly used, and some of the HTTP headers need to be even disabled in some circumstances. So what HTTP header would have, like details about the browser, the requested page, basically what page we're going to, what web server it hosted on, and different topics. Because HTTP headers had been used in different attacks, it's really important to secure those headers. Cross-site scripting is one of the attacks that actually take place in the security header, in the HTTP header. And a WASP is in a security header project actually outlines the methods how you can increase security and restrict from the vulnerabilities. Secure cookies. We've been talking before about cookies. It's information that saves in our web browser, so web pages will be loading faster, and next time maybe we don't have to enter the same information into the fields. And we need to make sure that our cookies secure, so they have a secure flag or attribute. We need to make sure there is no unauthorized access to these cookies, and that those cookies will be sent only over secure encrypted sessions, basically over HTTPS. If we're using cookies on the web, we have to make sure our web applications implemented TLS encryption on it. Procedures. So, stored procedures. SQL code, it's often saved, reused, in creating databases. And what happens, like, often actors use flaws in SQL, and they able to exploit those vulnerabilities to get access to the database. So what is SQL? SQL stands for, or another SQL, you can hear, structured query language. And it's um even it says it's programming language, it's actually not really a programming language. It's a language that allows us to build database and query information from the tables from that database. We need to make sure that we will prevent hackers from inserting commands into application. We already discussed this SQL injection, in a moment we're going to talk about this in more details. And there is nothing wrong with in using SQL. It's been used in web application development in databases for many years now. However, we always need to do input validation. Secure code review. So we have our written code, we have our application that ready to be deployed, and now we need to actually identify vulnerabilities, not bugs. Let's just say we already troubleshoot and fix the bugs, but actual vulnerabilities that would help different actors to exploit those vulnerabilities, basically hack our web application. So, white box testing is when we have entire source code provided to someone who will be able to review this code on a line by line basis. And black box testing is more as a penetration testing, when you have a application and uh, white hat hackers, ethical hackers, they would try to use different tools to check the code, to analyze and see what vulnerabilities can be found. Here's really important term that you need to understand is fuzzing. Fuzzing software is a testing technique. And in this testing technique, you will be able to find different errors, bugs, and also vulnerabilities in the code without seeing the code itself. Application vulnerabilities, just like any vulnerabilities, it's something that would put our application or our network in jeopardy. And why I say network? Because we also know that the network can be vulnerable, and through the web applications that connected directly to our network, someone would be able to get access on the server, and who knows where they will be able to get access after that. So let's talk about some vulnerabilities. On this slide, we can see integer overflow, and integer overflow attack is the attack against this vulnerability. So integer overflow is a condition where the arithmetic operation results in a number that is too large and is really cannot physically be stored in the memory, and the integer will be misallocated in the result. And in attacker will alter variables and make sure that the entered data would be large enough and not fit into the memory. buffer overflow. So I already mentioned this integer overflow, but buffer overflow happens when the data that we're sending into the memory is too large, and our buffer cannot accommodate all this data. So buffer is our actual physical memory, our RAM, and it stores temporary data, right? Data in the process. So buffer overflow is when we're running out basically of space on that memory. And buffer overflow attack, it's basically when attacker creates some type of exploit that would exploit this vulnerability and make our RAM, our memory, is not accessible. Data canary is also known as value placed at the end of the assigned buffer space, and it helps to overcome this data overflow attacks or basically prevent them. So here you can see basically how buffer overflow attack works. So let's just say we have this normal size of data and our buffer has exactly space for this data. And if we add anything to this normal length of data, we will actually get buffer overflow because it's not intended to keep that much data. Pointer difference. Pointer is a variable in memory that stores the address. We will see on the next slide visual representation of this, so you will be it will be easier for you to understand. But basically, it tells system, the computer, where different parts of data can be found in the memory. And pointer the reference error is basically vulnerability when the data will be collected from the wrong space of memory. Another name, object difference. And null pointer exception is an error that occurs when you receive value of null when you actually, not you, computer, um, is addressing to the valid memory area where data is supposed to be. So here you can see visual representation. So we have our memory as a storage, and we have some bits of data stored in the specific locations. So for example, AB02 and AB04, that's like physical locations in the memory. The pointer is basically the value that points to this physical location. Race condition. Race condition is one of really important vulnerabilities that needs to be addressed. Basically, when different commands simultaneously, lines of code, they also called threads, will be executed at the same time. And on the image on the left, you can see like knock knock race condition as an answer before it was asked who was there, right? So it makes sense, and race condition attacks happened before with the banking websites, where some attackers were able to transfer large amount of money because server side of the bank was not able to identify this race condition attack. Uh, Time of check to time of use, or TOCTO, it's a race condition in which incident of attack occurs in the time between software is verifying the state of the resource and actually using this resource. So that's exactly what happens when you get some type of resource, line of code, or thread, and it takes time for the system, for the machine to translate and verify the state of this resource. But attackers can use this time to implement an attack. Memory leaks are bad. We don't want any data that currently in the process and located in our memory to escape, and it's a big vulnerability that need to be addressed when web developers create actual application. So it can be a result of creating and storing values in memory that neglected to delete. Basically, there was no garbage collection from the RAM, and it can crash the application, or it's actually can expose some data that should not be exposed. And if attackers intentionally crashing the program by using memory leak vulnerability, it would basically a DOS attack, denial of service, because when application is crashing, is not servicing, so it's example of DOS. Okay, let's talk about different application attacks. Web applications, it's applications that run dynamically through the web browsers. As I mentioned at the beginning of this lecture, that majority of applications nowadays are web applications, and hackers becoming creative in order to hack, manipulate, exfiltrate data using these web applications. So on this slide, you can see multiple different vulnerability, not vulnerabilities, attacks that can be used against web applications, but we will discuss them in details in a moment. So first would be API attacks. API stands for Application Programming Interface. Basically, it's a tools and programs that enable to interaction between application and its components, and it also provides communications between client and server. And it is very often a point of attack when hackers use malicious program, malicious code, and they able to exploit any vulnerabilities within API. Example would be redirection of control of tasks. So API also always has this calls, which is like commands, what to do between front end and back end of the application. And if hacker would be able to redirect those calls, that would cause application to be inaccessible, or maybe this hacker will be able to redirect users of this API to different API and implement some malicious intentions on that application. Okay, I apologize. I think I skipped a few slides. Okay, injection attacks. Earlier I mentioned SQL injection, but SQL injection is not just one type of injection attack. So What is injection attack is when malicious code entered into web application through the some type of form where we can enter data, and the outcome of the inserting this injection code would be unpredicted, exposing entire database, one of those examples. So SQL injection, when we use to SQL language queries to input them in a input form and receive information within the web application. LDAP injection attack, basically when attackers exploit web application using lightweight directory access protocol. DLL injections, dynamic link library, and another one is commonly used is XML injection. Basically, when the script will be written to compromise XML applications on the web application. Here is an example of SQL injection attack. The meme from the one of the previous slides shows exactly the same attack. So basically, we entering in the enter field SQL query specifically designed to exfiltrate data, and web server would interpret this query as allowing access to the hacker to the entire database field. Like here, it would give the list of username and passwords. Cross-site scripting is also one of the common attacks on the web applications websites. Basically, it allows hackers to inject some type of script on the client side. Client side, basically like front of the page that users would be browsing, and it might not be even visible. Like user will be interacting with this website, and at the same time they will be clicking on some malicious link that might not be even look like a link. It may be like see-through layer. I'm trying just give you example how visually represent this. Like if on top of your image you had some plastic layer that is see-through, and you wouldn't be interacting with your website itself, the page, but you will be clicking on that top layer, and at the same time run different scripts like downloading some software that you don't need or infecting your system. Web application firewall actually helps to secure yourself from XSS attack. But again, firewall itself doesn't do anything if rules are not written correctly, right? Same as on network. So here's XSS attack, and XSS attack, it basically implements man in the middle. If you remember from one of the first lectures, we learned about man in the middle attack, when intruder hacker will get in communication between client and server, but here it will be communication in between user and web browser. Request forgery. It's attack when hacker is able to impersonate and forge a malicious session with the server. So basically, when the attacker will present himself as a legit user and will be able to get access to the data that normally he shouldn't have access to. So there are client-side forgery, request forgery, when vulnerabilities on the client side or front end would be exploited. So another name for this would be universal cross-site scripting. Server side, if you remember, validation of server side is harder, so attacks on the server side also would be a little harder. And in this point, attackers would be use HTTP requests to basically target website. And cross-site request forgery, or short CSRF, it's attack when tricks a web browser into executing unwanted action and manipulating application at the moment when user logged in this application. So it could be anything, even exfiltrating personal data of that user who currently logged in into the online website. As you can see as an example here, like banking website. User doesn't know anything. He logged in his mobile banking or online banking and interacts with as normal without having any idea that we have someone in the middle, man in the middle, who is collecting information about that user. Another name for CSRF is actually XSRF because it's cross-site, and everything that is cross-site you will see in abbreviation with X. So this is cross-site scripting attack, and we can see visual representation how it works. So user logs in into bank establish trusted relationships, but because we had this cross-site scripting in our browser, we were able to give access to our banking information in through this trusted communication established to the attacker. What is data exposure? Basically, when any sensitive data accidentally will be exposed to users or attackers. And how different that is from data breach. Um, in data breach, threat actors actually intentionally attempting to see this data, but in data exposures, it could be exposed through the unsecure and unsecure coding, basically, not safe coding. And yeah, it can be a result of developers writing poorly secure code. But it also can be exploited. It says here that it's different from because attackers often looking for vulnerabilities like this, and if it's easy to access to the data and expose it, it's also would be easier to breach the um, company that runs this web application. Privilege escalation. If I'm not a root on a system, I would say sudo su and get all the privileges. Well, technically, it doesn't work like this in web application world, but very much the same. If you are not the user on the system, but somehow you were able to penetrate the system using some user credentials, and you were able to identify vulnerabilities that will help you to exploit these vulnerabilities into making yourself a root, making yourself a privileged user, administrator of this account, of this web application, and you will be able to make some changes into this application or get access to sensitive users' data and so on. Clickjacking. Clickjacking is basically when different links, advertisement, or sometimes even a transparent page on top of the legit page that would make user into clicking on it. So with transparent page, it's easy. User might not even see and click on it, but often users don't even need that type of sophistications because it's very common for users to click on links and click on different buttons on applications and advertisement. So when users clicking on those, they might find themselves not where they should be and download malicious code on their computers. Session hijacking is a type of attack that occurs when between client and server or two different clients establish secure communication, and it can be encrypted, but we have men in the middle who were able to hijack our session and collect all this data that in communication in between us, or even alter this data. So as you can see, preventative steps would be using up-to-date anti-malware software and of course system updates. Typo squatting is one of the oldest attacks on the web browser websites. Basically, when you're using um, when attacker creates some type of uh, website that looks like real website but might have some spelling error in the name, and often users would like this in Wikipedia. As you can see, it's misspelled, right? So attackers learn that is easy to um, exploit this human vulnerabilities of mistyping. But often, what else happened is attackers will use some type of different alphabet when they create the URLs for their fake websites. And for example, you need to go to wikipedia.com, but for some reason you typed uh, wikipedia.net and you went to a malicious website. Directory traversal. One of the attacks when basically hackers get beyond the web server root, and it's bad because it allows them to not just expose through the front end, but being on the back end, being on the server, and having access to the everything that's saved on that server that running this web application. And as you can see, it allows hacker to bypass folder restrictions. So if this attacker already root on the server, he can do whatever he wants with that. And next slide is secure socket layer, SSL. So we no longer actually use SSL, but we still call our encryption over the communication sessions on the network as SSL for the encrypted, but actually we're using TLS, which is works similar, but SSL had been retired. So the secure socket layer or SSL striping is the when threat actor just removes this encryption layer and user wouldn't even know about them not running a secure encrypted session. And yes, it allows us to have ban in the browser attack when intruder of our communication would be able just to see everything between client and server without any encryption whatsoever. And the last one would be driver manipulation. So drivers is a software that helps our operating system to identify hardware it needs to work with. So it basically tells how different hardware that connected to our um, computer need to work with this operating system. And there are two types of driver manipulation attacks. First is shaming. So basically, using driver not as intended. And as you can see, it's very common practice in software development. And another would be refactoring, when we using attacker would be using these drivers, but they will modify them to uh, have some malicious intention and maybe change some behavior. Uh, what would be a good example of this when, for example, we would be installing our external webcam, and we will need to install drivers for this webcam to work with our system. And for example, if we had been attacked, installed drivers that been refactored, maybe this webcam will be constantly monitoring us and spying on us. Okay, so thank you for watching. This chapter is quite long and not easy to understand. So make sure you read the chapter 7. Make sure you go through book assignments after the chapter and try to test yourself with the Security Plus questions. I also would suggest you to answer questions after the chapter that will help you to identify how well you understood this chapter. Again, thank you for watching and have a wonderful day.